Hello and welcome to our special show on the tropical cyclones and how the Indian Meteorological Department is gradually gaining upper hand in tackling this brute natural phenomena by effective disaster planning, preparation and dissemination of early warning information. The extensive coastal belts of India are exposed to cyclone storms which originate in the Bay of Bengal and the Arabian Sea every year.
8:30 p.m. October 29, 1999. The super cyclone of the century struck the Odisha coast. With an intensity of about 300 km per hour, accompanied by a 7-meter high storm surge. Of the state's 30 districts, the 11 along the coast were badly hit. Over 10,000 were killed. The Odisha cyclone, also known as Cyclone 05B, and the Paradeep cyclone were the strongest tropical cyclones ever recorded in the North Indian Ocean since the one in Bangladesh in 1991. On the 25th of October 1999, a tropical depression formed over the Malay Peninsula. A day later, it had moved northwest, having turned into a tropical storm, strengthened further on October 27 into a cyclone. By October 28, it had become a severe cyclone with peak winds of 260 km per hour. This Category 5 cyclone, the most powerful in the scale of 1 to 5, lashed the Odisha coast on 29 with winds of 155 miles per hour.
Well, India has been constantly working in improving its observation systems both in oceans and on the land mass. And of course, the oceanic observations as far as cyclone is concerned are very critical. So we have deployed a large number of ocean observing systems, and in addition to that, the satellite observations have tremendously helped in better characterizing and monitoring the satellites.
It destroyed 2,75,000 homes and left 1.67 million people homeless. It also caused losses worth $4.5 billion.
The word cyclone was coined in 1848 by Henry Piddington, a British meteorologist, and is derived from the Greek word kuklos, that is the coil of a snake, as the airflow of the storm resembles it. These tropical cyclones, which are accompanied with very heavy rain, gales and storm surges, popularly known as waves, cause heavy loss of life and property almost every year.
When winds blow over ocean water, it lifts the water. That is how the waves are formed. However, when the wind is very strong, like in a cyclone, the waves can be killer gain waves. It is these storm surges that cause disaster. Although the falling tree in the heavy wind can result in damage to property and loss of life, usually it is the gain wave of water inundating low-lying areas of coastal regions that results in heavy casualty.
When I talk of development of model, you need to really have a better handle on prognosis of its genesis, its movement, both track and intensity prediction, and the point of landfall. And we have developed models to understand and predict all these aspects related to cyclone.
Storm waves result in heavy floods, erosion of beaches and embankments, damage to vegetation and reduced soil fertility. Flooding due to storm surges pollute drinking water sources, resulting in shortage of drinking water and causing outbreak of epidemics, mostly waterborne diseases. Very strong winds or gales may cause uprooting of trees, damage to dwellings, overhead installations, communication lines, etc.
How the characteristics of cyclones which are forming in different basins are varying with each other. Now, for example, we are having a very small basin, the Indian Ocean basin is very smaller, and therefore, the lead time we are getting right from genesis to the hitting of the coast is very small, whereas the Pacific and Atlantic basins are very large, and therefore, they remain on the ocean for a very long period, and you can really understand the cyclones in a better way.
Past records show that very heavy loss of life due to tropical cyclones has occurred in coastal areas surrounding the Bay of Bengal. Cyclones are also often accompanied by intense and heavy precipitation exceeding 40 to 50 cm in a day, or about 10 cm or more per hour in some places.
How to deal with such disasters? This was a huge challenge for the country as well as for its science community. Pure hard work, determination, focused research and latest technology led to the acquired expertise of Indian science in the field of timely prediction of such upheavals in the weather conditions. Science could not avert the cyclones, but it could save many lives by predicting them well in advance. It is the endeavour of the Indian Meteorological Department to minimize loss of human life and damage to property due to tropical cyclones by providing early warnings against them.
A Cyclone Warning Division or CWD at headquarters has been set up to coordinate and supervise the totality of cyclone warning program in the country. Cyclone warning bulletins are also issued to Doordarshan and AIR stations at New Delhi from Cyclone Warning Division for broadcast and telecast in different languages. The IMD department through its headquarters office in New Delhi provides cyclone information to control room. The Cyclone Warning Division has to assess the totality of cyclone situations both in the Bay of Bengal and the Arabian Sea, including Gulf of Oman and Gulf of Aden, irrespective of the area of responsibility of individual cyclone warning centers.
We are always striving to further improve the entire system, and this would call for better observations. We don't have observations, airborne observations when the cyclone is active, and then we really need to better characterize its properties, and for that you need better observations, in situ observations, which we don't have at present.
Various techniques are employed by the IMD for track prediction of the storm. The methods are based on climatology, persistence, and both climatology and persistence. Synoptic techniques, empirical techniques, satellite techniques, statistical techniques using climatology, persistence and synoptic, analog techniques, numerical weather prediction models. The Cyclone Warning Organization in India has a three-tier system to cater to the needs of maritime states. These are a Cyclone Warning Division set up at IMD headquarters to coordinate and supervise cyclone warning operations in the country and to advise the government at the apex level. Secondly, the area cyclone warning centers at Chennai, Mumbai and Kolkata, and cyclone warning centers at Visakhapatnam, Ahmedabad and Bhubaneswar. And third, the cyclone warning work is also supervised and coordinated by the forecasting division at Pune.
A better coordination mechanism which has been established by National Weather Service with other stakeholders, including Ministry of Home Affairs and DMA, the information dissemination mechanism has been really strengthened. Today we are able to reach out to all the possible stakeholders with minimum time loss, and that is what has really helped us to really combat the extreme weather events and the mechanisms which are related to the cyclones.
The cyclone warning centers issue bulletins and warnings for their respective areas of responsibility. These include sea bulletins for ship plying in coastal waters, broadcast of forecast warning bulletins through Inmarsat EGC Safety Met Service under the new GMDSS program of WMO for the ships in Indian Ocean, bulletins for Indian Navy, port warnings, fisheries warnings, and host of others.
cyclone warnings are disseminated to various users as per their requirement. So therefore, we have got various types of cyclone warnings. For example, fishermen, we have got fishermen warning. For ports, we have got port warning. For ships flying in the deep sea, we have got sea area bulletin. For the ports flying in the coastal waters, we have got the coastal weather bulletin. For the disaster managers, we have got the 4-stage cyclone warning systems. For All India Radio, we have got All India Radio bulletin. For press, we have got the press bulletin. For Indian Navy, we have got special bulletin called Indian Navy bulletin. Similarly, for civil aviation, we have got a special bulletin. So like that, in general, we have got 13 types of bulletins during cyclone period, which are issued every 3 hours, according to the requirement of various specific users.
The Cyclone Warning Division also performs the following functions at the international level: to serve as RSMC Tropical Cyclone, New Delhi; to implement the Regional Cyclone Operational Plan of WMO, Escape Panel on Tropical Cyclone; to prepare every year a comprehensive scientific report on the cyclones in the North Indian Ocean; to issue daily a tropical weather outlook for the North Indian Ocean to the panel countries; to provide cyclone advisories 4 to 5 times to countries like Thailand, Myanmar, Bangladesh, Pakistan, Sri Lanka, Maldives and Oman during cyclone epochs in Bay of Bengal and Arabian Sea. NHAC New Delhi has been designated in the Regional Specialized Meteorological Center for the cyclones. The probability of a correct forecast decreases with increasing forecast validity period. The mean forecast error for 12 hours is 50 kilometers. For 24 hours, it is 140 kilometers. For 48 hours, it is 300 kilometers, and for 72 hours, the mean forecast error is 500 kilometers. These figures are comparable to corresponding figures of other centers like National Hurricane Center Miami, which monitors Atlantic hurricanes, and Typhoon Warning Center Tokyo, which monitors typhoons of Northwest Pacific, etc.
But still, if you compare the errors, the best is the Atlantic Basin, the US, the National Hurricane Warning Center. They used to have the best skills, and now we are comparable. Of course, we are still about 50 kilometer error margin higher than what they have, but it's all comparable. So we are, I would like to say that at a global scale.
The Indian Meteorological Department has been providing 3 hourly advisories from 1999 onwards. The advancements in IMD cyclone tracking system includes the improvement in observational network including ocean, land and atmosphere, and quality of data supplied by Doppler weather radar, buoys, automated weather system, high wind speed recorders, satellite images and derived products from Kalpana, INSAT 3A, INSAT 3D and OceanSat 2. Fast communication for data exchange and warning dissemination, high power computing system and improved numerical modeling capabilities like GFS, WRF and HWRF. And lastly, the improved tools and techniques of forecasting, capacity building through research and development, training and national and international collaborations. The cyclone detection radars or CDRs were started during the 4th plan. They have proved to be a very useful tool to cyclone warning work. Cyclone detection radars are now functioning in Kolkata, Paradeep, Visakhapatnam, Machilipatnam, Chennai, Karaikal, Goa, Mumbai, Bhuj and Cochin. IMD has planned to replace existing high-power coastal cyclone detection radars by Doppler radars in a phased manner. Machilipatnam in Andhra Pradesh will be one of the sites where such a radar will be established on priority basis. 5 more such radars are planned to replace old CDRs. It is also planned to set up modern Doppler radars at Gopalpur on the east coast and at Mangalore, Ratnagiri and Veraval coast. Cloud pictures received from weather satellites are used extensively in locating movement of cyclones over oceanic regions, particularly when they are beyond the range of coastal radars. At present, facilities for receiving low-resolution satellite pictures from the polar orbiting weather satellite exist at Bhubaneswar, Mumbai, Kolkata, Guwahati, Chennai, Pune and Visakhapatnam.
Whenever any cyclone warning or any disaster warning is issued from the concerned division, say cyclone warning is issued by cyclone warning division, it comes to our system. This system is basically automated system, and it immediately transmits the alert messages to a group of officers engaged in relief as well as disaster mitigation through SMS, and the detailed messages are issued through email as well as to other means directly through our system to various stakeholders. So this way basically the disaster warning and alerts are immediately reaching to the relief commissioner as well as officers engaged in the disaster mitigation.
Cyclone warnings are disseminated through a variety of communication media. This is a unique scheme not tried anywhere in the world. The scheme has been extremely successful during cyclones for the last 24 years and gained considerable confidence of the Indian public. Designed by ISRO and implemented by IMD in the mid-80s, the CWDS is used all these years to disseminate cyclone warnings effectively. Selective addressing, which incorporates separate messages for each district, is done by transmitting a digital code followed by the actual warning message. Cyclone warnings are generated in English and other local languages including Tamil, Telugu, Oriya, Bengali, Marathi and Gujarati. Though the radio and TV broadcasts are for one and all, the messages through CWDS can be accessed only at centers equipped with the receiver and addressed specifically for receiving the message. CWDS is one-way communication system and will be complementary to other systems of cyclone warning dissemination. Facility of acknowledgement is available in the upgraded version of CWDS. The present CWDS network covers 252 stations spread across coastal areas of maritime districts along the east and west coast. Through assistance of the World Bank, the government of Andhra Pradesh had installed 100 digital CWDS receivers along the Andhra coast. A digital uplinking station also functions at Chennai for this purpose.
The All India Radio is the most effective means to reach out to the last mile connectivity, that is the people at the last end in the villages and the fishermen, etc. As you know, fishermen go into the sea and they can listen to All India Radio station nearby through the small radio set. And we have made a survey in recent years. According to survey, All India Radio is the most important means for dissemination of cyclone warning to the grassroots level. And also the other channels like TV, Doordarshans are useful for dissemination of cyclone warnings.
This specially designed system works via the INSAT satellite and provides area-specific service even when there is failure of conventional communication channels.
It is the 12 hours, the next 12 hours.
Warnings are issued for the general public, fishermen, farmers and different categories of users such as central and state government officials responsible for disaster mitigation and relief, industrial and other establishments located in the coastal areas, railways, aviation, communications and power authorities.
All these bulletins are disseminated through various various warning channels like telephone, telefax, email, website, and also for last 2 years we have introduced the SMS. So all the mobile holders get our bulletin through the SMS services, and for that purpose various service provider agencies are utilized.
IMD also operates IVRS, which stands for Interactive Voice Response System. Requests for weather information and forecasts from the general public are automatically answered by the system. For this, a user can dial a toll-free number 180018011717 from anywhere in the country. The system has been installed at 26 meteorological centers. Data on maximum and minimum temperatures and rainfall for a large number of town cities are also provided. Local weather forecast of cities and multi-hazard warnings include cyclone warnings are also provided. On the other hand, cyclone warnings are issued to state government officials in 2 stages. The first stage warning, known as Cyclone Alter, is issued 48 hours ahead of expected commencement of adverse weather over the coastal areas. The second stage warning, known as Cyclone Warning, is issued 24 hours in advance. Cyclone warnings are communicated to government officials and other parties by high priority telegrams, telex and telephones. Police wireless is also used as and when required. Reduction of cyclone disasters depend on several factors including hazard analysis, vulnerability analysis, preparedness and planning, early warning and mitigation. There has been vast improvement in forecasting technique and cyclone warning services in recent years. This has helped considerably in reducing loss of human life and limiting damage to property caused by cyclones. Satellite technique can now be used to find out the center and intensity of the system. It can also be used to find out various derived parameters that are useful for monitoring and prediction of cyclones and associated disastrous weather.
The warning services provided by IMD in recent years were highly acclaimed by the government and the media. In case of recent cyclone Cyclone, the planning went far beyond. Efforts to save people's livelihoods were also taken. Specific warnings were given to fishermen not to venture out to the sea and to put their boats in a safe place, while farmers were advised to harvest their standing crops.
About 25 years ago in 1999, a super cyclone struck a largely unprepared India. There was large-scale and unprecedented destruction and loss of life and property. Cut to 2013, a more menacing, more threatening cyclone Cyclone approached the east coast, but India had learnt its lesson.
We are always striving to further improve the entire system, and this would call for better observations. We don't have observations, airborne observations when the cyclone is active, and then we really need to better characterize its properties, and for that you need better observations, in situ observations, which we don't have at present.
Mock drills have been conducted. A better weather prediction system and communication system was in place. More than 350 safe shelters had been constructed. A prepared India swung into action. Almost 10 lakh people were moved to safe places. Weather forecasting scientists and administration worked in tandem. The loss of life was minimal. About 30 deaths were reported as compared to 10,000 in 1999. The lessons learned from 1999 proved crucial in reducing the magnitude of the disaster.
You really need to assimilate these observations, the new observations, into the models and improve the physics and other aspects of the model to further minimize the error structure in the model output.
Weather forecasting techniques and accuracy has improved tremendously since 1999. Data collection of over the past decade had made climate models more precise and accurate. We can track a cyclone more accurately and precisely now. Models have improved alongside the amount of data fed into them. The landfall of storm in 1999 was delayed by 30 hours. It hung near the coastline for almost 11 hours, causing maximum damage. Cyclone Cyclone made the landfall 3 hours after the predicted time. In 1999, preparedness for the Odisha government was poor at best. Andhra Pradesh was better prepared and helped Odisha overcome the disaster situation. Since then, Odisha has improved its disaster preparedness and management. It has built 200 cyclone shelters. The government runs schools, Anganwadis and community centers in these shelters to ensure regular maintenance. Under a World Bank project called National Cyclone Risk Mitigation, 148 more shelters are being built. 28 of them are functional and proved useful when Cyclone hit the coast. Means of communication and protocols have improved. The National Disaster Management Authority managed the channel of communication this time from the central government level to the district level. Timely communication ensured the authorities got 3 to 4 days to prepare. Evacuation was the key, moving people away from unsafe places. In the aftermath of Cyclone, Andhra Pradesh has set up its National Disaster Management Force, a recommendation that had been lying with the state government for many years. Both Odisha and Andhra have their own personnel to deal with disaster. Odisha Disaster Rapid Action Force and Andhra Pradesh State Disaster Response Force. Mock drills help check and prepare local authorities and people for disaster and help keep damage to a minimum. Since 2006, Odisha has been conducting a mock drill on the 19th of June in each area. Mock drills are conducted in areas like Jagatsinghpur district and Paradeep, which are more cyclone prone. This also helps in managing disaster and reducing casualties.
Around 76% of India's coastline is prone to cyclones and tsunamis, while 59% of the country is vulnerable to earthquakes, 10% to flood and river erosion, and 68% to droughts. With meteorologists warning that climate change will bring more severe natural calamities to the Indian subcontinent, states like Odisha and Andhra Pradesh have since invested heavily in disaster risk reduction projects. But according to disaster experts, not all states in India are as prepared as these two states. Some have not even established disaster management departments, or those that have are not functioning. It's imperative that countries like India must improve its planning and reduce the potential impact of disasters before they occur. Thank you for watching our special show on tropical cyclones on Rajya Sabha TV.